record it, right? Fine. So let's get started. So in the last class, so I have briefed you on the sensitivity analysis. There we basically look at three of the tools. The one is about the data tables. So there we discuss one-way data table and two-way data table. And thereafter we look at the goal seek command. And finally we discuss about the scenario manager. And the last class we couldn't discuss about your class activities. So today we are going to start with that. So at that time you didn't complete, maybe because of the exams you had. So we thought of starting with that, then followed by the briefing of the solver part 1. So that is our game plan for the day. So let's straight away go to the answers. So someone may take us through the first one. The first question, take us through that. The first case, the question will test you. So in fact, these are past paper questions even. So therefore, this will even give you some kind of idea about how you would be tested in case of the examination, and see whether you can manage something of that nature. So that was the purpose. So would like someone to initiate? Yes. Okay, without taking much time, let's get started.
Roshan, if they are not willing to show, let it be like that. No need to show the answers. Let them
Yes.
to practice. It's their duty to do that.
Yeah.
So let us basically discuss what we want to discuss today and finish it off.
Right, so sure. Right, so if you're not ready to share the answers, so in fact, even we were quite flexible. So you were supposed to do that by the last week, but no one did that at that time. So we accepted. That was because of the examination, but this week, so you promised to do that. But if you are not ready, no, we are not going to take you through that. So we may straight away go and brief the kind of the Excel solver, and that would be our today's session. Fine. So let me start with the solver. So this was the last week recording. So this is another important capability that is available in your spreadsheet package. So when you come to this solver, it's a kind of advanced application. Since you are in a kind of third year, so you have completed your management accounting and financial accounting, and also some finance related courses. So therefore, now we are in a much comfortable situation to absorb how this Excel solver works, because most of the things are depend on what you had learned previously. So in that, in the last class videos, we discussed about two application of this Excel solver. And the first application, we call it, it is optimal product mix. Optimal product mix. And the second one, it was about how to use this solver in capital budgeting. So that was our main focus was on. So we started the discussion with what is Excel solver. So there I have explained you together with the examples that, so it's a kind of tool that is available in a spreadsheet package, which would help to achieve a particular objective. So it may be a kind of maximization, or it may be a kind of minimization. But here the most important consideration is that subject to several conditions. So it will take you through achievement of a particular object objective subject to several conditions. Say for an example, if you take a business organization, so they would always try to maximize their profit. So therefore they would perceive the profit as one of their objectives. And if you imagine an organization where they will be having like several products. So if they are doing several products, in such kind of situation, they may have to make decision depending on the resources depending on the resource availability, what are the products that they are going to produce for a particular period of time. Say for an example, you may be producing say 4 goods, say A, B, C, D, something like that. And when it comes to the resources, so most of the important resources could be the materials and labor, let's say. So when it comes to these resources, you know, the resources, the supply would be limited. So resources are in limited supply. In such kind of situation, so how you are going to decide how many units that you are going to produce from each of the product, or what are the products that you are going to produce in order to ensure that the profit is maximized, given that the certain limiting factors are there. The limiting factors may exist as to the labor supply or sometimes the material. So therefore, in such kind of situation, how you are to maximize the profit. So that is something what we call the optimal product mix decision. So what is your optimal product mix? So when it comes to this solver, then we look at how to get this particular tool available in your spreadsheet package. There I have shown you. You need to go to this Microsoft Office and then the Excel option. Under that, in the manage box, you can add the Excel edits. So even in case of your examination, so you might find that in some situation it is not available. But you can't simply say that to us. It is something that you need to know and how to get that particular feature activated. So it is simply go to the file, then you can go to the options in the bottom. Then you can see the Excel options gets appeared. There you can go to this add-ins. So in the several tabs that is given, you can go to this Excel add-ins and you can say okay. Sorry, go to the options and it is add-ins. Yes. So once you go add-ins there, you can see at the bottom the manage is there. So there you can see a drop down list is also there. So out of that, you need to select this Excel add-ins, and by default it is over there. Excel add-ins is there by default. So all what you have to do to click on go. So then you can see several add-ins are appearing there. The analysis toolpack, BBA, Euro currency, likewise several kinds of add-ins are there. So out of that, we are going to select the solver add-ins. So if you are to select that, the tick mark has to be there in front, but here by default it is there. If it is not there, you need to certainly put that and say okay. So once you do so, so typically you are in the home tab. So if you go to this data, then there's a section called analyze. In that section, you can see the solver gets appeared. Solver gets appeared. And that's how you enable the feature. That's how you enable the feature. And if you look at the particular dialog box, what it appears once you click on this solver, the very first thing what it requires you to do is, first you need to set your objective. So for an example, you want to maximize the profit. So therefore, we are discussing about models. So therefore, the very first requirement is to develop the kind of basic model and get the profit worked out. So that is your starting point. And then you can simply make the reference over there to the objective. Then you need to specify what you want to do with that particular objective. Do you want to maximize that or minimize that, or you want to get that equal to a particular value, something like that. And thereafter, say it's maximization. You need to show you want to achieve that particular objective by changing what. That's what you need to specify. So in fact, that's what we are interested in. In a situation where you are doing several products, so if you are to determine what is the optimal product mix, so it's going to be your production plan. So it is going to be your product mix. So therefore you need to select that particular range. So if I'm just to do that, so here I have a kind of example taken. In fact, this is something that we have discussed. So accordingly, I might refer to the profit over there. I want to maximize that. I'm going to achieve this maximization by changing the product mix. So that is my changing variable. So now we have done certain things. It's about setting objective and what is the changing variables. By changing what you want to achieve this objective. And as I explained earlier, this solver may come into play in an instance where there are certain constraints. When the constraint exists, this solver may come into play. So in that, thereafter, you need to add the several constraints. So then you can simply click on add, and whatever the constraint that you may come across, you need to add that. So there may be some labor constraint, you may get them added. And there may be like material constraint, you may get added. And also sometimes the demand constraints, at any given point in time, your production plan cannot exceed the maximum demand. So you need to ensure that as well. So likewise, whatever the constraints that is mentioned or that is implied in the question, you need to get them added. So once you click a particular constraint, you can add it, and then you can add the second one. Likewise, you may keep on adding. And also you can see that when it comes to the constraint, different kinds of symbols are there. So it's like less than or equal. So it is equal, greater than, and integer, binary values, likewise. So we have experienced most of these aspects we have experienced during working out the questions. So having done that, once you add the constraints, thereafter most important thing what you need to ensure that, so we always make sure that the make unconstrained variables non-negative, or we call it non-negative constraint. So in that particular case, by default, it is selected, but in a situation where it is not, you may have to select that. So that is to ensure that the changing variables may not consist of the negative values. So it is explained even in your given text, but just to mention, that is to say the changing variables are not consist of negative figures. So thereafter, you need to do a most important thing. It's about the relationship between the dependent variables and the independent variables. So there you can see several kinds of relationships you can assume. You can assume a kind of non-linear relationship, a linear relationship, as well as a kind of evolutionary relationship. But out of these different kinds of relationships, we are going to assume that, so between the dependent and independent variables, there is a kind of simple linear relationship. So therefore, we may go by this simplex LP. So we may select that, then you can say solve the problem. So once you click on that, immediately the results get appeared over there. Results get appeared over there. So thereafter, you can even have the option to take the answer report as well. So we may experience that when we are working out the questions. So that is basically about this solver tool. Yes, before we move on to the discussion of a question, what I had discussed so far, if you have anything to get clarified, yes, now it is time for you to get them clarified. Right. So even after discussing the question, you can come up with uh, the questions what you have. After discussing the activities, if you have questions, yes, you can come up with that. So at the moment, so I have just provided kind of introduction. So let us go and work out one question. So in the given material, we have given two class activities for this optimal product mix. So in that, we have worked out both the questions during the video session, the video recording of the lecture. Now what I'm going to do, I'm going to take, in fact, we have discussed three activities. Out of that, I'm going to take one activity and going to take you through that. And this is one of the past paper questions as well. So there I select activity 3, the Dress Fox, a company specialized in men's clothing, manufactures t-shirt in 3 sizes. You can see small, medium, large, and also some of the informations are given. Thereafter, the fixed cost being given, and then it talks about like, yes, there's a question. Yes, good question. There it asks that, are there any order in when you are adding this constraint? Or we can add them as we wish. Yes, there's no particular order. But the thing is, what you need to ensure that you have added all the constraints. At the end of the day, you have ensured that all the constraints are being added. So that's the most important thing. There is no such kind of order, right? Good. So likewise, whatever the confusion, questions that you may have, take that. Then we have the fixed cost being given. Then it talks about some of the constraints. The first one is material constraint. The purchase manager advised that because of the shortage in supply, material supply is limited to 12,000 meters per annum. You know, always the resources are limited. So therefore, it is indicated the materials are in short supply. Similarly, the human resource manager has indicated that the labor is also in limited supply, especially the skilled labor. But at the same time, the sales manager has accepted a kind of order to supply a particular minimum number of goods, so where you need to attend for sure. Even it may not be the profit maximizing formula, but still you need to cater that, otherwise it will harm the long-term business relationships. And finally, it mentioned that the production plan should consist only of completed unit, but I believe that this is something should not be given. So it is something to do with your common sense. You know, if it is kind of production, it's kind of units, so there can't be fractions. So in a given question, if it is not even mentioned, you need to mention, you need to ensure that the particular constraint being added, that all the production plan consists that the integer values. So that is another kind of constraint. So that is the situation. Out of that initial information I have taken, let me just take these constraints information somewhere outside. And the one thing that you need to remember always, it's all about models. So what you do is developing accounting models. Hence, you need to adhere that the first you develop the model. The model need to be developed first, right? So accordingly, you may start with the given information. So you were given information about material, you were given information about direct labor, you were given information on variable overhead, likewise the information are given. Also the selling price, the maximum demand, those aspects are given. Then the question also says that the fixed cost is 1 million. So therefore I might identify the fixed cost as well. Fixed cost is 1 million. Now, what are the information that you would require? It depends on the requirement. Let's see what is the requirement. The requirement is determine the optimum production plan to maximize the profit per annum. So that is the requirement. So you want to maximize the profit. Hence, definitely you need to work out the profit. Give me 1 second.
Roshan sir, what happened? Your mic is mute.
Sir, give me 1 second. Somebody is in a call. Give me 1 second, sir.
Roshan sir. Okay.
Okay, sir, I have come back. Yes. So it's about the profit maximization. So we may identify the profit as our output. Then what we need to figure out, what is the optimal product mix. So in order to get this profit done, so when you are given information like this, since the fixed cost is given separately, this is a kind of question that relies on the marginal costing. So therefore, you better first identify the contribution, and then you can identify the total contribution. Once you deduct the fixed cost, you may arrive at the profit. So therefore, you may have to add a particular input that is called the contribution per unit. So depending on the given information, so let's get it done. So the selling price is given, and you may deduct the whatever the variable cost that is given. So you are given the variable cost. It is material, direct labor, and variable overhead. So you can see for the small t-shirts, there is a contribution of 350 per unit. Then we have the medium and the large. You can simply drag them and get the contribution. So now you have the contribution information. Then what you need to do, if you have a kind of production plan assumed, you can work out the profit. So since I mentioned that, as you even did in the case of this goal sheet, by assuming certain figures, you are going to initially develop the model. So accordingly, I'm going to assume some production plan, and that particular production plan is going to be like, let me say 500 units, 300 units, or 200 units. I might just assume a particular number of product, and that is my product mix. Now I have all the required information to work out the profit. So how I might get? So you were exposed to the sum product. So by using this sum product function, you can multiply and get the total of the range. So otherwise you may have to do it individually by considering each and every kind of cell separately. But here, if you apply this sum product, you can do that in a more efficient way. You can do it in a more efficient way. There it gives you the option to multiply and get the total of what you call the range. So we may get the contribution per unit. First, I might select that particular range. Then you need to give the corresponding range. The corresponding range is going to be your product mix. It goes from 500, 300 and 200, the corresponding values. So once you get that, you can see that the total contribution comes. The total contribution comes. From that total contribution, if you deduct the fixed cost, and that is your profit. That is your profit. So depending on the product mix that we have assumed, we can see that at the moment there's a loss of 545. It doesn't matter. What matters is you're establishing the logical relationships. As long as you establish the logical relationships, that's it. So here you have done it. You take the total contribution and you deduct the fixed cost, and thereby you arrive at the profit. So that is the starting point. Now let's consider about the constraints what we have. In the question we saw that the first constraint is the t-shirts are made from linen material. The purchase manager advised you that because of the shortage in supply, material supply is limited to 12,000 meters per annum. Right. Now you can see there's one constraint that is about the labor. If you consider about the availability of labor, it shows that the availability is 12,000 per annum. So I might just take that it is availability. Then you need to identify the corresponding usage. So that is what you need to compare. You know, at any given point in time, your usage cannot exceed the availability. So it is a pretty straightforward thing. So therefore, I might identify the usage depending on the model what I have developed. So if I write it like the availability should be always greater than or equal to the usage. For my reference, later reference, I might take it as this. Now, how you are supposed to get the usage? So then you have to think. So what you need to know. So you have the production plan with you. You are planning to produce 500 small t-shirts, 300 medium t-shirts, and 200 large t-shirts. So that's what you are planning. So if you can work out what is the labor hours that is required per one unit, you can simply multiply it by the number of product, and thereby the usage can be arrived. So that's what you need to do. So therefore, I might add another input that is called labor hours per unit. So this is something that is not given, but for sure, in a question of this nature, you might have to work that out. You need to identify the labor hours because the labor hours availability is a kind of constraint. In order to figure this out, the information is given in the given question. It says that the direct labor, if you go there, rupees 300 per hour. It costs you rupees 300 per labor hour. So accordingly, if a small t-shirt comes at a direct labor cost of 450, you can work out how many direct labor hours is involved. How you get? It's 450 divided by 300. You can see it is 1.5 labor hours, and it's 2, and if you can further add that, it is 2.5. Now you have figured out what is the per unit cost. Okay. Now we can work out the usage. How we do? You can simply take again the sum product. Otherwise, you need to take that lengthy approach. Take the labor hours per small t-shirt and get them multiplied by the production plan. Then you need to add the labor hours per medium, and that is to the production units, and add the labor hours per large t-shirt and multiplied by the production plan. So likewise, you need to do that separately, and it's not an efficient way of doing. So we always agree that you need to uphold the principles of model development. You need to be efficient. So in that, you may get this sum product. There you can simply do the job. You can easily take labor hours per unit range and get them multiplied by the production plan. So once you get that, you would end up making to the kind of usage. So at the moment, depending on the production plan, what we have assumed, our usage is 1,850. So that's totally fine. So it's about our first constraint. Now the second constraint. So it talks about the material. Sorry, I have taken that labor. It should be availability 10,000. No? Mistake. Sorry, availability is 10,000. Sorry, I have missed that. When it comes to the material is maximum. There would be 12,000 meters available. So you may take that materials. Again, availability 12,000. So you can take the similar approach. Again, you can identify the material per unit, and if you get them multiplied by the production plan, you would be ended up getting into the usage. Again, your material is greater than or equal. The availability must be always greater than to the usage. You can apply the same approach. The question gives you the information as to the material cost per meter. Then you can work out material per unit. Material per unit. So the material meter cost you 400. If the small t-shirt would cost you 600 for material, then you know how much material is required. It's 600 divided by 400. It's 1.5 again. You can simply drag that, and again you can get the per unit requirement. So therefore, to the model what you have developed, you need to identify even the materials. So I might highlight these are the things what I had added, newly added. I start with the basic information given. So depending on that, I have identified several inputs. I have identified several useful inputs or the minimum required inputs. So it is something that we add. Again, you can simply get the usage. How you take? It is about the sum product. Get that? You start with the material per unit. Again, the range can be multiplied and the total can be taken. The production plan. So you can see that at the moment, all what we have used is 2,100. So that is our second constraint. Then if you go further, you can see that the sales manager has already accepted an order for 300 small, 200 medium, and 400 large t-shirts. So in a way, that is a minimum production. Minimum production. So you can consider that also as a kind of constraint. In fact, it's a constraint. So at whatever the cost, you need to do this minimum order. So therefore, I might identify this minimum production as my constraint. So there we have that small, medium, and large. Small, medium, and large. So we have accepted that particular order for like 300, 200, and 400. It's 300, 200, and 400. Right. So that is the order what we have accepted. So since the question says that the final one, production plan should only be consist of completed units, we are going to say that the production plan is a production plan and should be consist of integer values. That is also your constraint. So therefore, we can see that there are explicit constraints 1, 2, 3, 4. The question has mentioned 4, but you need to be conscious. You might find another. It's about the maximum demand. So that is also a constraint because at any given point in time, the production plan cannot exceed the maximum demand. So therefore, that is also in a way a constraint. So accordingly, like 5 constraints are there in the given question. So before we move on to applying, the solver would like to answer some of the questions that you may have. So if you have any questions, doubts as to this basic model development, yes, would like to answer that. So you can see that this is built on the most of the things that, or I would say almost all of the things that you had learned. But the only extension what I see is that, so while you were in the second year under the management accounting, all what you did, so you managed to work with one constraint. But here, so depending on the capabilities of this spreadsheet package, we are working with several constraints simultaneously. So that is the beauty of this spreadsheet package. Yes, would like to hear you if you have any questions before we move on to. Yeah. So can you explain the binding and non-binding part shown in answer report? Okay, right. So let me take you through that once I generate that binding and non-binding variables consideration. I might take you through. Okay. So let me move on to the application of this solver. So you may go to the data tab, then you may get this solver. So there you need to, so here some of the things are taken. Let me remove it because earlier we have said that the first thing is you need to set the objective. So now it is quite clear you want to maximize the profit. So you may refer to the profit output. You need to maximize that by changing what? What is the changing variable? It's about the production plan. Production plan. So you may get that. By changing the production plan, you want to maximize the profit. Now you need to add certain constraint. We'll start. See how we are going to add this constraint. See that? So there is a clear guide. It says that here you can add the cell reference. And when it comes to the constraint, you should add it over here. In case of the examination, or when you are applying this, the things where it can go wrong, sometimes you might change the two sides. So therefore, be specific. You need to always take the cell reference over here and the corresponding constraint over there. So accordingly, if I start with the labor, it's like 10,000 availability. It is my constraint. So therefore, I might take this usage to the cell reference. So this is my usage. It should be less than or equal. It should be less than or equal to the availability. So you need to logically establish that, right? Then you can simply add it. So now it's been added. Moving on to the second one, it's about the material constraint. You can see you start with the material usage. It should be less than or equal to the material availability. So that is the second constraint you are added there. Then the next one, it's about the minimum supply. So you need to ensure that at any cost, your production plan is going to satisfy this minimum requirement. Minimum requirement must be satisfied. So therefore, this time it is your production plan must be greater than or equal. It needs to be more than or at least equal to the minimum production. So therefore, it must be greater than or equal to the minimum production. So you may add that. So that is the minimum production constraint. And it says that the production plan should consist of completed units. So it is about integer values. So your production plan must be the integer values. Integer values. The fourth constraint that is being added. Moving on to the fifth one, it's about the maximum demand constraint. At any given point in time, your production plan cannot exceed the maximum demand. So therefore, your production plan should be less than or equal to the maximum demand. You may get that. Now you have added almost all the constraints. Say OK once you finish adding that. Then you can see the constraint what you had added has comes over there. So you need to ensure that this particular tick mark is there, and that is what it ensures the production plan consists of only the positive figures. It is not the negative figures, so therefore we make it non-negative. And most importantly, the relationship, what we are going to assume, it's about the simple linear relationship. So having done that, you can simply solve it. Then it asks you, now you can see the answer has changed. Your original answer was like a loss situation, but now it's clearly a profit situation. Then the solver would ask you, so do you want to keep this solver solution, or you want to restore the original values? So in fact, once we get that, what we want is to keep the solver solution. So therefore, we may go by that. And on the other side, you can see that there's a kind of report comes over there. So it's what we call the answer report. In order to get that, you need to highlight that. You need to select it. Once it is selected, you can simply say OK. You can simply say OK. Let's see. So with that, you can see the answer is retained. The solver, the updated situation is there, and also the corresponding answer report is there. So once you get a kind of answer report like this, the most important thing is you need to have some kind of interpretation skill has to be there. The minimum required interpretation skill would be required. So how to interpret the whatever the report that is generated. So it is straightforward. It is quite easy. You can see that it mentions about the objective cell. Objective cell. Originally, you saw that we were in a loss position. We were in a loss position, but under this constraint, what is the maximum profit that we can go for is 1.55 million. We can go for, subject to this constraint, we can go for a profit of 1.55 million. Then we have the variables. So it's about the changing variable what you get. And here you have the values that you have originally assumed. It's 500, 300, and 200. But subject to the constraint, now you have come into the product mix, 500 units, 1,500 units, and 2,500. So if you had defined these cells earlier, even it may come in a with the relevant range name. So it comes like small, medium, and large. So that is something you can do when you are performing this solver solution. Then you have the constraint. You can see that when it comes to the constraint, there it calls binding constraint and non-binding constraint. So when you come to these two constraints, you know, the binding constraints mean that is the constraint what will hinder your profit potential. It's a major barrier, depending on the situation, it's a major barrier to maximization of the profit. So if you look at the first one, you can see that it's 10,000. It is cell D21. D21. Let's see what is that D21. Our D21 cell is, it's about our usage. And you can see that the available labor is 10,000 units. So here what you have done, you have used all the labor. So therefore, the labor is a biggest constraint for you, because you cannot increase your production because you do not have adequate labor with you. You have used that to the fullest. So that's what we call the binding constraint. So it is a kind of constraint, so that will hinder your profit potential. So because of this particular constraint, you cannot go for a higher profit. So it's a binding variable. Similarly, the material one, that is also binding. The material availability 12,000. According to this production plan, you have used everything, right? So therefore, that is also another barrier to maximize your profit, because you have utilized it to the maximum. You have utilized it to the maximum. Then what you have, the third one, it's a non-binding constraint. It's a non-binding constraint. It's B15 and B9. What is B15? Let's see. B15 and B9. Yes, it's about the maximum demand. So when it comes to the maximum demand, it's a non-binding constraint. So you can see that at the moment we are producing 500. So therefore, with no problem, if the other resources are available, you could have gone even up to the 10,000. So at the moment, there's a slack. There's a slack. So there's a slack of 500 units. You could have even gone for 500. So similarly, in the next, that is about 1,500. Yes, 1,500 and 3,000. You can see that the maximum demand is for small, medium, and large. Sorry, small and medium. It is not a kind of binding constraint. But if you look at for the large one, yes, you have gone to the maximum. You have gone for the maximum. So the maximum demand is 2,500. You have utilized that to the fullest. So therefore, it's a binding. So it's 500, 1,500, 2,500. It talks about the minimum. So the minimum is not a kind of binding constraint. So you have this minimum requirement in each of the situation. So you have simply exceeded that. So therefore, it is also not a binding constraint. It's not a binding constraint. And that's what we call the binding and non-binding. Yes, Lakshita, did I answer your question? Right. So this is a kind of basic understanding what you need to have in a question of this nature. So would like to hear any question. Yeah. Yes. So if you have any question, would like to answer that before we move on to the second application. This is about one of the application of Excel solver. So you can do many out of that. This is about the optimal product mix situation. So I believe that, so especially those who are involved in the management accounting, especially the management accounting side of a business organization, so you make more sense out of this. Didn't understand the minimum production part. So that is in the sense the constraint that you are referring. So here you have the minimum constraint. So it's a kind of constraint. So when it comes to the kind of product mix decision, so you may always wanted to produce, sorry, you may always wanted to produce whatever the product that gives you the highest profit. So that is what you need to do. But the problem is that in the presence of a minimum production requirement, irrespective of the profit what it gives, you need to ensure that at the end of the day, you have supplied this minimum production at any cost. So therefore, it's a kind of constraint. So in the absence of this minimum production, you would have gone for a kind of different combination. But since this particular minimum production requirement is there, it is also a kind of constraint. But when you come to this particular situation, though there is a kind of minimum requirement, it is not a kind of issue to you. So the minimum constraint serves as like 300, 200, and 400 units. But when it comes to our production plan, we have simply go and produced something definitely higher than that. So therefore, in a way, it is not a kind of constraint. It would have been a kind of constraint if you, in one instance or something, you have produced the minimum requirement. So for an example, instead of producing like 500 units from small shirts, if you had produced 300, so in that we can see that it works as a kind of constraint. We have done the minimum required in such an instance. But here you can see that clearly in any of these products we are quite high, we are quite above them. So therefore it does not affect us. More than minimum production, we consider it as a non-binding constraint. Yes. So in fact, that is the case. So if this really works as a binding constraint, what you would have ended up doing is like 300 units, isn't it? If you really producing 300 units, it tells you that, so you are doing this simply to satisfy that particular requirement. So that is where it becomes a kind of binding. But here you can see that clearly it is not a barrier to us. So we are simply go and producing from all the units what we have. And when it comes to the production, you can see that we are producing even higher than that. So if you are really constrained by that, we would have only produced the minimum required. But here, there's nothing as such. There's nothing as such. So that is why we are saying that it's a non-binding. Okay, good. So likewise, would like to answer whatever the question that you may have. So these are things that we have even discussed in the video recordings as well. So here we are simply summarizing, but in a way that's a kind of lengthy discussion. Right, if you're fine with that, so let's move on to the second application what we had discussed in the last class. Yes, again, another important application of this solver. If I go back to the lecture material, it's about the capital budgeting. Even you can apply this Excel solver in the context of capital budgeting. In the context of capital budgeting, you can apply this solver and you can come up with what are the profitable investment opportunities that you may have. So, you know, when it comes to a kind of investment of an organization, so their starting point would be they would be searching for different investment opportunities. Say that you have the feasibility to invest in like 3 projects, but you may be initially search for like 8 to 10 projects. 8 to 10 projects you may look for. Then out of that, so depending on the resources, especially the finance resources, the labor resources what you may have, you may stick to 1 or 2 or 2 or 3 projects. So that's what you do in reality. You know, it's always the resources are limited. Resources are limited. So sometimes you may have adequate finance to undertake whatever the project, but you may do not have enough labor to do that. So sometimes you may have enough labor to do whatever the project, but you may not have the adequate finance. So likewise, the organizations are always constrained. We are always constrained. So that is the reality. So when it comes to such kind of constraints, so how we are going to decide some of the kind of investment opportunities or projects which would maximize the value of the business. So the value of the business in the sense that is the greatest NPV value. So therefore, what would be the projects that is feasible for you, which would maximize the value of the business? So it's something that comes from the finance, what you had learned during your second year, and even under the management accounting, those aspects would have discussed. And here we are going to try that in a computerized environment, even in the presence of several constraints, not just a one, but it may be more than one constraint. Again, here also we have discussed about two activities. We managed to discuss two activities, activity 4 and 5. But out of that, I might take one activity. In fact, this is some of the past paper questions as well. So we have tested something as such. The marketing and research division of the company has analyzed the net present values of different market segments. You are given the details. So you are looking for different kinds of market segments to enter into. It is woman t-shirts, the men shirts, woman skirts likewise. And also you are given the required investment and the corresponding NPVs. So once you appraise that particular project, what was the kind of NPV? And also the labor that is required for each of these segments, each of these investment is identified. Then the question says that the maximum investment that the company can afford is 6 million. At the moment, all what we have is 6 million. And the maximum labor hours that is available with us is 25,000 hours. So therefore, in a way, those are kind of constraint. And also the investment cannot be divided. Investment cannot be divided. So you have mutually exclusive projects. You can either accept or either reject. You cannot go for a kind of half of the investment. That's not going to work. So that's what it indicates. So that is the situation. So again, when you are approaching a question of this nature, starting point is the development of the basic model. You may start with the development of the basic model. You may start with the given information. So I might copy and paste the constraints somewhere. Right. Now you can see the different segments are taken, investment, NPV, and labor is taken. So here also the constraints are there. You might need to identify that. So again, the model development comes first. You need to first develop a particular model. So considering these requirements, so when you work out the investment or the capital budgeting related question, most of the time you need to have a structure similar to this. Out of the many projects, you need to decide what are the projects that you are going to accept and what are the projects that you may reject. So the acceptance and rejection is known by ones and zeros, and we call it binary values. Binary values. It's all about ones and zeros. So again, we can assume some of these projects that we may accept, the sum of the projects we may not. So I might simply go and put 1 0 1 0. Likewise, I might simply put several kinds of decisions. So at the moment, I have decided to implement women t-shirts to go and invest there, and women skirts and women's jeans. Likewise, I have simply assumed some of the project to be undertaken. Then the most important thing is that here you are going to do what? So it comes in the requirement. The question says that determine the investment that the company should undertake in order to maximize the NPV. So this time your objective is to maximize the NPV. So how do you maximize the NPV? So first you need to figure out a kind of NPV figure. Then by using the solver, you can decide how to maximize that. So therefore, I might first identify the NPV. So when you are getting this NPV, you need to take it in a structured way. You should not do that by simply looking at the first project you are going to accept. So therefore, you might take that NPV. Then the second one is not, but the third one, so you may go and pick that. And the third one is not, but the fourth one. Yes, this is the answer at the moment, but here it compromises the flexibility of the model. You know, it will work only for this situation. But you know, once when it comes to the model development, you need to ensure that the flexibility is there. The flexibility must be there. Then what must be the ideal way of doing that? Again, applying your knowledge on some products. You can apply your knowledge on some product, and simply you can take the acceptance and rejection decision and get them multiplied by the NPV. So what we can do, so even so when you are taking that, you need to think about, even you are going to identify the labor hours required and also the investment that is required. So therefore, in a way, you want to keep this acceptance and rejection column constant. Hence, I might make it constant. And then the array 2, you can keep it relative. You can keep it relative. So it's 1700, say, okay. So you have ended up getting the same, but the approach is different. Now you have identified what you need to maximize. It's about the NPV. The NPV maximization, in the sense you are maximizing the value of the business. And how you do that? By accepting and rejecting certain projects, depending on the resource that is available with you, right? Now the question says that the constraint. When it comes to the constraint, you can see that the maximum investment that the company can afford is 6 million. The all what you can afford is going to be 6 million. So therefore your investment availability would be 6 million. And when it comes to the labor, sorry. So now you have identified the investment availability. Now let's see what is the usage of funds. The usage of funds. How you get that? It depends on the project that you accept. So therefore, if I'm to work out the usage over here, you can simply take the sum product over here, and the exception and rejection can be taken, and the investment column can be taken. So I might make them constant. And if you take this investment, you can see that the investment that comes as to the projects what you are accepting. So it comes as 6,500. You accept in the first one 1,500, third one 3,000, 4,500. Yes, it is 6,500. That is perfectly fine. Again, if you are to just have a kind of constraint written down, so it's like, it's always the usage has to be less than or equal. Less than or equal the availability. Availability must be the greatest. But at the moment, these are some of the assumed figures. So therefore, it is something about that. It's fine. Then the next thing, it's about the labor. The labor availability is like 25,000 labor hours are only there. And again, the usage can be worked out. You can take this sum product, and how you get the acceptance or rejection. It's F4, and it's about the labor. Right, we may get that. So initially I thought of getting this labor usage and investment usage over here. That's why I just make this the first one kind of constant. But later I feel that this is more convincing. If you take the availability and the usage in front of that, you are taking that in a more convincing way. So that's why I have changed the plans. Right. Then the next thing is investment cannot be divided. You can simply take it as a kind of constraint. Okay, we have identified everything. Yes, anything that you want to get clarified before we move on to the application of the solver tool? So when you come up with the question of this nature, so you might have to model the answer in this particular kind of nature. So depending on the requirement, most of the time you might require a kind of structure like this. So in the very first one or two questions, you may get used to that, but once you get used, so it may naturally comes to you. Right, okay, shall we go and apply that? So you can go to this solver, then you are going to set the objective. What is that? This time you want to maximize the NPV. So select it. By changing what? By changing the projects, what you may accept and what you may reject. By accepting several projects. But when you are going to do so, the constraints are there. That has to be added. The one such constraint is that your investment, the usage must be less than or equal to the availability. So that's one. The second one is about the labor. Your labor usage must be less than or equal to labor availability. Then also the investment cannot be divided. So therefore, when it comes to your changing variables, you're going to say that it is either 1 or 0. And we call it, it's binary. It's binary. So those are the three constraints, what it appears at the moment. And you can say, okay. So make sure that make unconstrained variables non-negative. Assume the relationship is always simple, linear. Now if you run this, then you can see this must be the desirable projects that you should go ahead with. So earlier you have planned for something else, but now you can see that it has been changed. So according to the new situation, by satisfying the given constraint, so what you can achieve is 1,550,000. So you may get the answer report as say okay. So again, if you go to the answer report, you can simply read it like that. Original values, final value is there. So then the original values and final values of the variable cells, those are the investment project that you may accept and reject. And also the constraints are there. So when it comes to the first constraint, you can see that it is binding. What is that? It's about the investment. Investment is a binding constraint. The available funds is 6 million, and for the projects you have used everything. But what about labor? Though the labor is available 25,000, all what you had used is 19,000. It is a non-binding, and it's going to be binary values. That's it. So that's how you structure and answer the question in capital budgeting. Yes, now we would like to answer your question. So if you have any, yes, take that. So these were the two applications what we had discussed in the last class. So at the end of the today's class, we are going to open up another two applications. So you can kind of study during this week. Yes, Callum sir, anything to add, sir?
No, everything is clear, I think. Only thing, if you want to explain them, this accept reject section is the thing what we need to enter by thinking our own. Later on, it will be working according to the real situations, right?
Yeah.
So you should not skip anything, right? All the projects need to be either selected or either rejected, right?
Rejected, yes, yes. That's the most
And
important thing. Yeah.
put 0, 1 only for halfway. You should complete for all projects, right?
Yes, so that is, yes, good. Thank you very much, sir. So when it comes to that, when you are, what do you call that, when you're structuring the question, that you need to ensure that, so you have, in the first instance, you have taken all the option. It may be either accept or reject, but ensure that for all the given investment opportunities, you might need to indicate that. So that is the most important thing that you need to remember in case of the examination. So because it's something to do with binary values, ones and zeros. Yes, Lakshita, yes, we are assuming that all the projects are mutually exclusive. Yeah. Can't there be project that must be accepted? Yes, in a given question, it might say that, so you must definitely, out of this project, you must accept, say, men's gene or something. So if the question says that, it is also work as a constraint. It also work as a constraint. You need to ensure that the men's gene is equal to 1. So that is something that you need to ensure. So there can be different kinds of constraint. Even you can, so according to your thinking, you can expand this and try the different things out. Try the different things out. So it's your imagination. And yes, so we have observed that over the 2 weeks time that, so here we may do all the video recordings and we may upload the things, and also we may come and brief the things. But it seems that the required commitment may not come from your end. So that is not something we expected from the very beginning, that so we are seeing that there's a kind of deterioration in your commitment. So in the initial period, we experienced something different to that. In fact, that's what even motivated for us to come and go for an extra mile. But if you are doing something, if you continue this particular practice, so probably we may not so taking you through the briefing in the upcoming session. So in the next week, so we are coming with a kind of macro. So it would be kind of pretty much complicated area. So if you are not ready to take that, so we may have to think it. So how we are going to deliver that? So we can just do a video recording and uploading. That's it. So that is all what is expected, but we are going this extra mile and putting an extra effort to make sure that at the end of the day, you are getting everything perfect. But so if you're not ready to accept that, then we may have to think that twice. So the last week we allowed that, yes. So it is on the reasonable grounds, that's the case. But here today, but still you are not ready to do that. That's fine, right? And when it comes to the assessment, so we are going to have our next assessment. So it's based on this sensitivity analysis, more or less, and we are going to have that on this coming Sunday. That is in the sense that fourth of Sunday. We are going to allow you like 20 minutes time to do that, as we always used to do. So we are allowing that particular time, and we are going to start the test at 9 p.m. So it's 9 p.m. Sunday, we are going to have your next test. So with that, we would have completed 4 tests. There is one more class test to go, and we are done with all the case studies. In fact, we are in the process of marking that. So probably in 2 to 3 days that we'll be uploading your marks as well. Then you can have understanding where you stand. Right. So that's what we need to discuss. Kalam sir.
Then we can wind up, no?
Yes, sure. Sure.
So we have 2 more lectures, right? Only.
Yes, we have 2 more lectures. One is on macro, the other one is going to be the past paper discussion.
Yeah.
Right. Okay, then thank you very much, sirs. Thank you very much. Good night to everyone.